trapezoid is a quadrilateral with one pair of parallel sides. When we have a trapezoid, we have two bases. We have the top base and the bottom base, and the other two sides of the trapezoid are called legs. The only special property of trapezoids is that they have one pair of parallel sides. And that's pretty important because what we have here is parallel lines cut by a transversal. So the upper base angle and the lower base angle directly below it are supplementary to each other. So for example, if this is a 60-degree angle, this one would have to be 120 because they are same side interior angles formed by parallel lines, so they would have to be supplementary to each other. In this question over here, first we need to find angle B. We have two angle measurements, 90 and 90, and we have a third one for 30 degrees. If I add up all of these angle measurements together, I have 180 from the 90 plus 90, and 180 plus 30 is 210 degrees. Since all four angles of any quadrilateral add up to 360, I'm going to take 360 minus 210 to see what this missing angle is, and that is 150 degrees. It says now to explain why we have a trapezoid. So take a look. The upper base angle and the bottom base angle below it, 90 plus 90 is 180. Take a look here. The upper base angle and the lower base angle below it, 150 plus 30 is 180. So since we have supplementary same side interior angles inside the lines on the same side of the transversal, on this side as well, these are same side interior angles also inside the lines on the same side of the transversal. We have supplementary same side interior angles. That is one of our ways of proving that lines are parallel. So ABCD is a trapezoid because it has one pair of parallel sides. We don't have a rectangle here, even though we have a right angle, because in order to be a rectangle, first of all, it needs to be a parallelogram first. And I don't know that ABCD is a parallelogram because I only see one pair of parallel sides right now. I don't see another pair of parallel sides, and in order to be a parallelogram, both pairs of opposite sides would need to be parallel. Additionally, if it was a parallelogram, rectangles should have all 90-degree angles. And 2 out of 4 of the angles of this quadrilateral are not right angles. So we do not have a rectangle here, even though there is a right angle. Here's some information on isosceles trapezoids. Isosceles trapezoids are special kinds of trapezoids that have congruent legs and congruent base angles. When I say congruent base angles, I mean the two upper base angles are congruent to each other, and the two lower base angles are also congruent to each other. Here I have an example. We're starting out with isosceles trapezoid ABCD, and we want to prove that AC is congruent to BD. Here is AC. It is a side of this triangle over here. And here is BD. It is a side of this triangle over here. And when we have overlapping triangles, a strategy that we like to use to work with them is to take the triangles and to draw them separately on our paper. So that is ADC, and this is BCD. When I have overlapping triangles, remember, I will always have a shared side. Here, DC is in both blue and yellow. And if we look at the separated triangles, DC and DC have the same two letters, so they're congruent to itself by reflexive property. We knew that we had an isosceles trapezoid here. So we know that the legs are congruent. And we also know that the base angles are congruent. Isosceles trapezoids have congruent base angles. We can get congruent by SAS. And then it would be one more step to say that AC is congruent to BD due to CPCTC, because CPCTC because they are corresponding sides of the two congruent triangles. I'm going to pause the video and write this proof up real quick. So here we started off with the information that we had an isosceles trapezoid, and we actually proved that AC and BD were congruent. AC and BD are diagonals of this isosceles trapezoid. So what we proved here is that when we have an isosceles trapezoid, they have congruent diagonals. That is our third special property of an isosceles trapezoid. They have congruent diagonals. Over here, we have a coordinate geometry proof. What we need to do here is we need to prove that we have a trapezoid, but not an isosceles trapezoid. In order to prove that we have a trapezoid, we need to show that one pair of sides is parallel. That's going to require using the slope formula. If we can show that two sides have the same slope, then we know that they are parallel to each other, making it a trapezoid. To show it's not an isosceles trapezoid, after we first prove it's a trapezoid, we have two options. Either we can find the length of the legs and show that they are not the same. That's with the distance formula. Or we can find the length of the diagonal and show that they are not the same. That would also be with the distance formula. The reason for that is if it were an isosceles trapezoid, it would either have congruent legs or congruent diagonals. So if it doesn't have that, it would prove it's not an isosceles trapezoid. I'm going to pause the video and write this proof up. First, I proved that one pair of sides is parallel, showing it's a trapezoid. And I did that with showing that PR and PA are parallel to each other, meaning that they have the same slope as each other. And notice how I ended with the concluding statement. Since ABCD has one pair of parallel sides, it is a trapezoid. You do not have to show that the other two sides, TP and RA, are not parallel. I did that here. They don't work out to be parallel, but you don't have to show that. As long as it has one pair of parallel sides, that means that we have a trapezoid. And then in order to prove it was not isosceles, I showed that the legs had different lengths. If you take a look, both of the legs TP and RA have different measurements from each other when I plugged into the distance formula. Once again, I did end with a concluding statement explaining why the trapezoid is not isosceles. Okay, here we have a numerical question. And over here, we have that AB is parallel to DC. And we also know that AD is congruent to BC. We do know that this is an isosceles trapezoid. Now, remember, when we have an isosceles trapezoid, any trapezoid actually, since they have parallel sides, the same side interior angles are supplementary. So every upper base angle and the lower base angle directly below it will be supplementary to each other. And in fact, since it's an isosceles trapezoid, the base angles are congruent to each other. So if this is 3x plus 5, this one is also going to be 3x plus 5. So we have 2x plus 3x plus 5 equals to 180 degrees since they're supplementary. So that would be 5x plus 5 is equal to 180. 5x is equal to 175. Let me get my calculator out. 175 divided by 5 is 35. And the question is asking us to find the measurement of angle BAD. So that would be 70 degrees if we do 35 times 2. Over here, we have another numerical question. First, we are finding the measure of angle DBC, which is this angle right over here. So we have triangle DBC, and in the triangle, we already have the 30-degree angle and the 70-degree angle. 30 plus 70 makes 100. This angle here has to be 80 degrees in order to make the 180 degrees that all angles of any triangle have to add up to. The next part says to prove that ABCD is an isosceles trapezoid. So we have another triangle up here. And in that triangle, I have a 40 and a 30-degree angle. 40 plus 30 is 70. So in order to make 180 degrees, this last angle, angle A, would have to be 110 degrees. Now notice, if I add up this 80 degrees and this 30 degrees, that is also 110 degrees. And then on the bottom, if I add up this 40 and 30 degrees, I get 70 degrees, which is the same as this angle over here. So notice the upper base angles and the lower base angles are congruent to each other. So that is one of our properties of isosceles trapezoids, that the base angles are congruent, and we have that here. So I'm going to put it over here. Since the base angles are congruent, the trapezoid is isosceles. And then it's just to solve graphs. Now, since now I know it's an isosceles trapezoid, I know it's got the special properties of isosceles trapezoids, so I know the legs are congruent to each other. So I'm going to set up an equation, making the two legs equal to each other. I'm going to add 21 to both sides, and I'm going to subtract x from both sides, and I have x is equal to 13. Over here, I have another example with trapezoids. So here we're told that AE is congruent to BE, and we're also told that DE is congruent to CE. And finally, they tell us that DC is parallel to AB. And we need to prove that we have an isosceles trapezoid. Remember, before we can have a trapezoid, before we can have an isosceles trapezoid, we first need to prove that we have a trapezoid to begin with. I can already see that we have a trapezoid because they already gave us that DC was parallel to AB. So as long as it's got one pair of parallel sides, quadrilateral trapezoid. Now, in order to show that it's isosceles, they gave us AE congruent to BE, and they also gave us DE congruent to CE. If I can get AD congruent to BC, then I would know it's an isosceles trapezoid because then it would have congruent legs. And I can get that because I have these longer segments and I can make them shorter with subtraction. If I take AE and I subtract off BE, I'll be left over with AD, which is one of the legs of the trapezoid. And if I take BE and I subtract off EC, I'll be left over with BC, which is the other leg of the trapezoid, and I'll be able to prove it's isosceles. I'm going to pause the video and write up this proof. You should try to do the same. And here is the full written up proof with showing that it's first a trapezoid and then showing that it's also an isosceles trapezoid. Feel free to pause the video so you can take a look at it. Okay, we're going to take a look at this next example now. So this is another proof that we're going to be writing. And here we're told that we have an isosceles trapezoid. And the bases of this trapezoid are DC and AB. And the non-parallel legs are AD and BC. So I'm going to mark DC and AB as parallel since those are the bases of this isosceles trapezoid. And trapezoids do have parallel sides, one pair of parallel sides. They also tell us that angle CDE is congruent to angle DCE. And they tell us that AE is perpendicular to DE and that BE is perpendicular to CE. So I know perpendicular lines form right angles, so I just marked my right angles into my diagram. And first they want us to prove that triangle ADE is congruent to triangle BCE. So since I know I have an isosceles trapezoid, I know that the legs are congruent to each other, so I'm going to mark that in. And also, in this triangle at the top, triangle DEC, I have two congruent angles in that triangle. So if a triangle has two congruent angles, the sides opposite from those angles are also congruent. That's the converse of the base angle theorem. Once again, if we have a triangle with two equal angles, the sides opposite from those angles will also be congruent. So now I have enough information to prove these two triangles congruent, DEA and CBE. Sorry, I should name them like the question. Triangle ADE and triangle BCE. And that's by HL because I have right triangles, I have congruent hypotenuses, and I have a pair of congruent legs. There are other ways to do this proof. You could use the fact that the base angles are congruent and subtract off the congruent piece to be left over with the piece inside the triangles, and then you would have AAS. But I think this is the most direct approach. I'm going to do it with HL. I'm going to pause the video and I'm going to write up this first part of the proof. Remember, in order to use HL in a proof, you do first need to state that your triangles are right triangles. So after I stated that angle DEA and angle CEB are right angles because of the perpendicular lines that form right angles, I did also state that the two triangles are right triangles because they have a right angle inside of them. And then later on, my HL is valid because remember, HL can only be used for right triangles. So you do have to specifically state that you have right triangles. Feel free to pause the video if you need a minute to take a look over this part of the proof. The next part is to prove that triangle AEB is an isosceles triangle. Now that we've proved triangle ADE and triangle CEB congruent, we can just use CPCDC to say that AE is congruent to DE because they're corresponding sides of the two triangles that we just proved congruent. And now we know that this triangle is isosceles because a triangle with two congruent sides is isosceles. I'm going to pause the video and write up the rest of the proof. And here is the rest of the proof. Feel free to pause the video if you need another minute to look at it. Okay, we're going to take a look at this next question over here, the next question. So we have trapezoid ABCD with parallel bases BC and AD. And they give us some information. They tell us that EF is congruent to EG. They tell us that AF is congruent to DG. And they tell us that BG, which is the side of this triangle over here, just noticing that, is congruent to CF, which is a side of this triangle over here. All of these things are going to be helpful to us. And what we need to prove is that trapezoid ABCD is isosceles, and they're even giving us a method to do that in this question. They want us to show that legs AB and CD are congruent. So I've already identified two triangles that could be helpful to us because they have BG and CF as sides. And look, they also have the legs that we want to prove congruent as sides. So these look like a really great choice of triangles to focus in on and to try the proof congruent so that we could just CPCTC the legs after that. So that's BAG, and this is CDF. And from the givens, they did tell us that BG was congruent to CF. That's a lot clearer now that we have it marked in separated triangles. I also noticed in this triangle in the center here, triangle FEG, from the givens, we know it has two congruent sides. So if a triangle has two congruent sides, we know it also has two congruent angles, right? Isosceles triangles have two equal sides and two equal angles. In a triangle, congruent angles are located across from congruent sides. So across from this congruent side is right here, and across from this congruent side is right here. And that's the base angle theorem. In the separated triangles, that's this angle, and that's this angle over here. Now, I also see that they gave us information about AF and DG, but AF is not the full side of this yellow triangle. AG is. That's the whole side. And DG is not the full side of the black triangle. DF is. That's the full side. So we can use addition to take the small pieces and make them into the full sides. If I take AF and I add on FG, I'll get the full side AG, which is what I want in this triangle. And if I take DG and I add on GF, the same segment, I will get the full side of this triangle, DF, which is what I need to prove the triangle's congruent. Then I'll have proved the triangle congruent by side angle side. And then it's just one more step to CPCTC the legs AB and CD that I need to prove the trapezoid is isosceles. I'm going to pause the video and I'm going to write this proof up. Here I have the proof completely written up. Feel free to pause the video to take a look. We are going to do one more proof in this video. Oops. And here is the last one we are going to do in this video on trapezoids. And here we are given an isosceles trapezoid. And they tell us that AB is parallel to DC. And our goal is to prove that angle 1 is congruent to angle 2. And this is going to be a really quick proof. And the reason it's going to be really quick is because When we have an isosceles trapezoid, the base angles are congruent to each other. And these two angles are supplementary, and these two angles are supplementary. And since these are congruent, and together these have to add to 180 and these have to add to 180, these have no choice but to be congruent to each other. They're supplementary to congruent angles, so they have to be congruent. To make it more clear why that's true with numbers, say like these were each 60 degrees because they're congruent. So whatever one has is the other one has to be because they're base angles of an isosceles trapezoid. Well, together these make 180, so this would have to be 120. And together these make 180, so this would have to be 120. So these would have to be congruent to each other. And that will be no matter what measurement these are, because these are congruent. And since these are supplementary, they have to be whatever that number is to make 180 degrees with congruent angles that are already there. So when we have angles supplementary to congruent angles, they are congruent to each other. We can say that in a shorter way by saying supplements of congruent angles are congruent. These two angles, angle 1 and angle 2, are supplements of congruent angles. So they have to be congruent. I'm going to write this proof up. It's going to be really, really quick. That is going to be 1, 2, 3 steps. So it ended up being a 4-step proof with my givens. In order to use supplements of congruent angles are congruent, you do first need to state that these two angles are supplementary to each other and that these two angles are supplementary to each other. So that is in my proof in step number 3. And then I can say angle 1 is congruent to angle 2 because they are supplementary to congruent angles, so they have to be congruent. Once again, for short, that is supplements of congruent angles are congruent.